Hello, everyone, and welcome back. This lesson is going to be all about the most important theorem in all of calculus. Okay, well, I'll be honest, it's probably not the most important to me, but a lot of people call it that because the mean value theorem is used to prove other really important things, like it is used to prove the fundamental theorem of calculus. It is a cornerstone foundation for the class, we'll say. However, you're going to look at it and say, that's completely ridiculous. It is another one of our existence theorems, so that makes it super fun. And on this picture up here, you can see basically what it's all about. Essentially, it's saying if a function is continuous on a closed interval and differentiable on the open interval. First note, this one is closed from A to B, and the next one is open. Why is that? Well, actually, on a closed interval, you can't take the derivative of the endpoints. We're not allowed to find that. That's not differentiable, so we'll use that as a nice starting point. But essentially, we're saying, hey, you've got a smooth curved graph with no breaks, holes, or anything else. Then it says, essentially, in this statement up here, the average rate of change between the two endpoints, so between A and B, we found the slope, the average rate of change, has got to be equal to the instantaneous rate of change at least once on that interval. And you can see for this particular graph, there are 2 points. The tangent line up here, the tangent line down there would have the exact same slopes. Whatever your average rate of change is, there must be a point on there where the instantaneous rate of change is the exact same number. And I say at least one because there could be many or even an infinite number. So that's the mean value theorem. Rolle's theorem is actually the exact same thing. It's a special case. And to be perfectly honest, I used to make fun of this till I realized Rolle came up with this theorem before the mean value theorem was created. But it's the same thing, except we're saying if you have something that's continuous and differentiable, and you have 2 points at the same height, then there must be at least one point where the slope's 0. Now, Rolle used this to find or to ensure that there was a maximum or a minimum somewhere. So if he picks out a point A and B and they're the exact same height, this function's continuous and differentiable. I know the way it's going to curve from A back to B again, there must be either a maximum point or a minimum point on there. It's not very exciting. As a matter of fact, you won't really need to remember Rolle's theorem in any special way, other than the fact that it is the mean value theorem when the slope is 0. Because when we say A and B have the same height, that means their average rate of change is 0. So this statement right here is the same as this one up here when A and B have the same height. Those are the theorems, and I'll give you a chance to look at some examples of how you could possibly use those in just a little bit.